All right, finally got everything formatted the right way, and we got that set up here. I'm going to cover this final answer so you don't see it yet, but we got to go through the steps to know how to get it. They're usually looking for critical points, which are the x-intercepts. If it crosses the origin, which would be 0, x-intercepts would be any point where we have some number, comma, 0 as the coordinate for it, and any other places specifically where this quadratic equation would turn up, or turn down, or turn up at that point. While the x may continue to increase, the y value rather for that coordinate will go down or go from that point go up. All right. So to do this, we kind of start with the first step, which we've already done for us. Setting it equal to 0. No, looking at the first step and then trying to factor out any x's from that x side if you just have it set equal to a y, and that would result in an x times 4x squared minus 3 equals y. So it's past the x origin, and then we have 4x squared is equal to minus 3 is equal to 0. So effectively saying now we know this one's going to give us 0 because anything times that other side will give us a 0 to meet the x. So we have one point here that's represented by 0, 0, 0, 0. The next one will be based on this term. We said this term alone equal to 0, and we have 4x squared equals 3, x squared is equal to 3 over divided by 4. Find the square root of that entire fraction, gives us the square root of 3 plus or minus 2, right? Which really means you have two numbers here represented by 1, a negative square root of 3 over 2, and a positive square root of 3 over 2. So these are the two x coordinates, and the x-intercepts in addition to origin. Because origin is an x and a y coordinate, a y-intercept. All right, now here's how we find the maximum and minimum. We're going to take the first derivative of the original equation, y prime, find the zeros, and plug those back into the original equation. All right, so we have y is equal to 4x cubed minus 3x. Y prime, applying our understanding of derivatives, is 12x squared minus 3. We said that equal to 0. Therefore, it'd be 12x equal to 3. X squared, 12x squared equal to 3. X squared is equal to 3 over 12, equaling 1/4. X is equal to 1/2, or x is equal to negative 1/2 being the possible scenarios. Kind of showing right here, right? So we plug these two values separately into the equation and separately into the original equation, y, not y prime, and we have that original equation is 4x cubed minus 3x. Once again, we just plugged in that 1/2 here and a negative 1/2 there. Respectfully, after we solve through, we have a negative 1. We plug this in for the y, and we have a 1 on this end for the y. So that gives us the two maxima and minima, or the places where there's a turn in the graph, right? So we got this point, this point, this point, this point, as well as what this represents, which would be infinity, and this one would represent which would be infinity. All right, so the critical points that I see and how I've been taught to kind of look at it is here, right? The final answer, negative infinity and positive infinity, are included in this graph, and they're there. Remember, it's a parabola. It's a quadratic equation, so they go on forever and ever and ever and ever. We have a negative square root of 2, 0, right here. We have 0. We have a positive square root of 3 over 2, which equals 0, right here. Our maxima, or a place where we turn, would be at negative 1/2, 1. And we have another one here where we have a 1/2 negative 1, right, where it turns back up. And these obviously considered the critical points in this particular graph. As I said, this is when it was a relatively vague writing of it. We had to use the derivative as well. I do want to reinforce that it's key that you do understand how to find the first derivative for numbers that for terms rather in any equation. But other than that, this is pretty simple. So I think pretty simple, but rather pretty direct. Want to make sure this is clear. And if you have any questions, please leave comments. Please make sure we go over this. And thanks for letting me know. And once again, thanks for your time.